Continuing on with section 7.5, we are focusing on logarithmic equations today. Just a quick review. How did we solve this first one here yesterday? What was our process? We move the 3x in front after we've done what? We have to take the log of both sides first, right? Then we can expand that left side and move the power in front. So taking the log of both sides was one of our techniques. What did we do for questions like this first one? We got a common base. That was the other method, okay? So when we were solving exponential equations, if we could get a common base, great. That's the fastest route. If we can't, then we can use logs to solve it. Today we're looking at log equations, and we're going to use their exponential form to solve it. So we're just going back and forth between those two forms. A logarithmic equation is an equation that includes one or more logarithms that involve a variable. It is important to check our solutions. Okay? Do you remember when we graphed logs? Remember what shape they were? Yes? We ended up with pictures like this. Okay? And there was a very specific cutoff for our domain, right? We couldn't go left of 0. Everything in our domain was higher than 0. So there are domain restrictions, right? When we take the log of a number, that needs to be a positive value. So whatever we put in here is going to have to be positive. Okay? So when we solve a log equation, we have to make sure we go back and check to see if when we dump that number in the equation, is it creating a situation where we're taking the log of a negative? We can't do that. Okay? So you may get some extraneous answers again. All right, so first one. We have a single log on one side. So our technique here is to rewrite it exponentially. What is the base in this one? Base 10, okay, common log. So picture there being a little 10 here. If it helps you, write it in, okay? And then we're going to rewrite this exponentially. So we say 10 to the 2nd, right? The answer in a log is always the power from your expression, okay? So we're taking 10 to the 2nd power, and we have to get back to a 4x minus 3. Well, if I write it like that, 10 to the 2nd power equals 4x minus 3, that's just a linear equation. What's 10 to the 2nd power? And we can solve this. You've been doing that for several years now. What would we do? Add the 3 over, and then divide out our 4. Okay? Now again, checking our answer. If we put 103/4 back into our question, we've got log base 10 of 4 times 103/4 minus 3 supposed to equal 2. The 4's here are going to cancel out, right? We're timesing by 4, dividing by 4. We have 103 minus 3, which becomes 100. Is log base 10 of 100 equal to 2? Yes. Okay, so it works. All right, our next one. We have log of 3 minus 2x equaling negative 1. Again, our base here is a 10. So if we rewrite this exponentially, 10 to the negative 1 power has to give us that. Okay? What is 10 to the negative 1? 1/10. So we have 1/10 equals 3 minus 2x. Then what would we have to do? Subtract the 3. If we have 1/10 or 0.1, we subtract 3, we're in the hole 2.9. Yes? And then if we divide that by 2, what do we end up with? Okay. Plugging it back in to check. Log base 10 of 3 minus 2 times 1.45 equals negative 1. 2 times 1.45 is back to that 2.9. 3 minus 2.9 is 0.1. Is the log base 10 of 0.1 equal to negative 1? Yes? 10 to the negative 1 gives us 1/10? Okay. How is this one different? There aren't logs on both sides. You might run into some questions that are like that, where you have a log on both sides. In this case, we have 2 logs on the same side. If this side had been a 0 instead of a 1, I would move 1 log to each side. Okay? Because if I had the log of something equaling the log of something, these two somethings have to be equal. So the logs basically just disappear. Okay? But I can't do that on this one because I have 2 logs on one side and I have a different number on the other side. So the technique here, the trick to doing these is to condense it first. If you have a log plus another log, when you condense it, it turns into what? Multiplication. So we're going to write this as the log of x minus 3 times x equaling 1. So I've now condensed it down to a single log. Okay. Now I can rewrite it exponentially, like we did on the first 2 examples. So my base is 10. 10 to the first power gets me this. Well, 10 to the first is just 10. On the right-hand side here, if I distribute, I have x squared minus 3x. How would I solve that? Yes. Bring the 10 to the other side, subtract it over. And then what? And then factor. Okay, so just like you've been solving quadratics all year, 2 numbers that multiply to be negative 10 and add up to negative 3. All right, so possible x values would be a positive 5 and a negative 2. All right, we do need to check those. So if I put a 5 back in here and here, now I'm saying the log of 2 plus the log of 5 equals 1. That's okay. All right, I'm not taking the log of a negative. So that should work out fine. If I put the negative 2 in, though, what happens? Now I'm trying to take the log of negative number. That doesn't work. Okay? So the negative 2 is going to be extraneous. My only solution would be the 5. Okay? And again, if you wanted to check it, when we put a 5 in there, we have the log of 2 plus the log of 5 is supposed to equal 1. When we condense that down, the 2 and 5 get multiplied. This becomes the log of 10. Is that a true statement? Our base is 10. 10 to the first power gets us 10. All right, so the 5 is working. The negative 2 isn't. I do want to be very clear. It doesn't mean my x value can never be negative. What it means is when I plug it back in, what I end up taking the log of can't be negative. Does that make sense? So let's say I was doing the log of 5 plus x. Well, if I put a negative 2 in there, now I'm just taking the log of 3. That's okay. I can do that. Does that make sense? Okay. All right, I'm going to pause the video. I want you guys to talk at your tables. How would you condense this one down? All right, so once again, we have 2 logs here that we have to condense down. So we are going to have the log of what? 6 divided by 3x equals negative 2. Okay, what's my base? 10. So 10 to the negative 2 equals 6 divided by 3x. Okay, what is 10 to the negative 2? 100. And I'm going to have you leave it that way as opposed to a decimal because we can just cross multiply this. Okay, 3x times 1 is 3x. 100 times 6 is 600. Dividing out a 3, we get 200. Okay, checking it. Can I put a 200 in here without creating a negative value? Yes. All right. Tell me what you would do. Let's say we had 2 times the log, I'm just going to put some variables in here, of a plus 3 times the log of b equaling some number. How would you condense that? Put the 2 and 3 back. They were powers, right? When we condense it, they go back as powers. Now, if this, well, let me finish this one up. So I'd put this back as a 2. Whoops, sorry, as a 2. Yes? And then I could condense the addition back into multiplication. If I only had one of those pieces, like say my question was this, then I don't have to put the 2 back. I can divide it to the other side. Does that make sense? But I can't divide it to the other side without creating problems on that second log piece on the earlier example. Okay? So watch for those front numbers in front of a log. You might have to put them back as powers. All right? So you guys are going to do 32 to 44, 52 and 50 to 54, 56, 62, 64 to 71. And I want you to try 79 and 80.